Hello everyone, this is Jay from BTYT Tech Library. Today we are going to solve LeetCode problem number 11, container with most water. The summary of this problem, given an integer array, use distance between indices as width, and each value as height. Find the maximum area of composable rectangles. With one condition, when selecting the height, choose the minimum height between two candidates. One naive solution is we can calculate every composable rectangle's area and compare it one by one. On Cartesian coordinates, x-axis, we can take 2 points. From the fixed point far left 0, gradually scan right to the array's last index. We take the minimum heights and calculate the rectangle's area in every scan and then update the maximum area. Once we finish to scan right, then we will move the left point to one step right and repeat the scan. Implementing this to code. We need 1 point left, starting from 0 and gradually move right until the array's last index when each scan cycle is finished. And we need another point, right, which is always in front of the left point and be the scan destination to the array's last index. So in nested 2 loops, we calculate current rectangle's area with distance between the left and the right point as width, and take the minimum value of 2 points as height. Let's run the code. So this could be the solution, checking every possibly existing rectangle's area and comparing it to another. But can we do better? Because it seems like overdoing and too repetitive. And its time complexity is big O of n squared. How about this? We know the maximum area of a rectangle is, of course, maximum width times maximum height. So let's assume on maximum width, far left point and far right point, it has the maximum area. But it's just an assumption, so we will sacrifice 1 unit of the width in exchange for finding the new maximum height to green up for trade-offs with diminishing. Okay, then which point we should sacrifice? It's the minimum height. Because of problem's condition, it would have no effect if we choose instead of the minimum height. If we should roll the dice, let's change our shortest height to get the possibly taller height. And it's totally okay scenario because we already contains the maximum area from our assumption. So if we get the smaller area, then we already have, we just don't update. In this way, we need only one scan on closing window, which is time complexity big O of n. Now it's coding time. In this time, we need two pointers positioning at the edge of the array's indices. Selecting the minimum height, calculating and updating the max area logic is same. And we keep roll the dice for the taller heights betting our maximum width. While our windows of opportunity opens. Let's run the code. For the maximum or minimum output, the two-pointer technique is frequently used for the optimized solution, calibrating two variables in the controlled context. And at that time, it almost certainly comes along with the programming language's max or min comparison functions.